We're going to use the linear factors theorem and the conjugate zero theorems together to give us information about a polynomial function. We are not given the function, so you can't go hunting for the answers and then interpret them. You have to interpret this information from the theorems themselves. The linear factors theorem says that an nth degree polynomial can be factored into n linear factors x minus c1, x minus c2, x, sometimes we use r for root, minus c3 instead of c, x minus cn, where c1, c2, cn are the zeros or roots. And the constants here, these constants can be rational, irrational, or complex. Now, we're told we have a polynomial of degree 13 whose coefficients are real numbers. And we are given 1, 2, 3, 4 complex roots. These two are a conjugate pair. I know that 5 plus 4i must also be a root. And I know that negative 5i must also be a root. So the conjugates of these other two must also be roots. We want to find another zero of r of x, and either one of these that I've just stated will be accepted. So either 5 plus 4i or negative 5i, but only one because it only asked for one. The maximum number of real zeros that r of x can have, I know I have to have at least 6 complex zeros, right? Because of this. Those all have to be zeros. So for b, there are 13 total and at least 6 complex. So at most 7 real. Okay, and then the maximum number of non-real zeros, there have to be 13 total. And the complex have to come in conjugate pairs. So only 12 of them can be complex, which means the maximum number of non-real is 12. Right? Because everyone has to have a complex conjugate zero included as well. So there's at least one real zero.